This is section 2.7. This is part 2. We just talked about the very basics of interval notation, and we are going to end up solving some inequalities. So let's get another property, and then we will solve them, and you can start to see how all of this comes together. The first thing we have is the addition property of inequality. And this says if A is less than B, then we can add the same number to both sides of an inequality and it will still be true. This is also true for subtraction. This is exactly the same rule we had for equations. We are allowed to add the same number to both sides of an equation, and we are allowed to subtract the same number from both sides of an equation. This works exactly the same way. The biggest difficulty here is that we have a tendency to stop paying attention and write an equal sign instead of an inequality. But as long as you're paying attention to that, these are pretty easy. Let's look at z minus 8 is greater than or equal to negative 7. Just like solving an equation, I want to get my variable by itself. And what we do is basically the same as before. I have a minus 8 here. I want to move it to this side. So I'm going to add 8 to both sides. And that gives me z is greater than or equal to negative 7 plus 8 is 1. Okay, so we've done the algebra. We have to know how to write our answers. We're going to need to go to interval notation, and we're also going to graph. Now, it is really easier to graph first and then use your graph to find interval notation. MyMathLab separates these problems into 2 bits. It forces you to write the interval notation first, and then the second part of the question comes up and it asks you to graph it. It is going to ask you to do both every time. Just on your paper where you're working the problem, do the graph first, and then find your interval notation, and you will just enter it into the computer in the opposite order, okay? This is a number line. The only number I absolutely must see you write down, the only number that's absolutely important is the number involved here. So I have to have a 1 on here, okay? Now what I'm going to do, and you might want to do, especially until you get a good idea which way this is going, is you're going to put some other numbers on here. Negative numbers go to the left, positive numbers go to the right. Okay, now look at your variable. Which side is this on? Whatever number I put here needs to be bigger than or equal to 1. Think about it, pick some numbers. Is 0 bigger than 1? No. My answer is not going to be on this side. 2 is greater than 1. 3 is greater than 1. All of these numbers are greater than 1. So what we want to do is we want to shade the side of this number where all our answers are true. All of them are true over here. Now I use a squiggle to graph. You could just shade it darkly. You could use a highlighter, colored pencil, whatever it is you want to do. Okay. Now I have to put something on the 1. If you learned the old method, because we have an equal to right here, you would have put a closed-in circle right there and you would have been done. Now we use the same notation we use for interval notation. Because this has an equal to on it, I'm going to put a bracket right here. Okay? All my numbers from 1 all the way up forever are part of my solution here. Okay, so how do we get, this is the answer to my graph. This is the graph part of my solution. How do I get interval notation off of this? It's always going to be, you're always going to look at what you have shaded. You're going to describe your left-hand boundary, which is 1, and then describe your right-hand boundary. Now this goes up forever. It goes up forever in the positive direction. So that we say that this goes up to infinity. You don't put the infinity on your graph. It's not part of your graph. But it is your right-hand boundary. If my graph had gone this direction, it would have been negative infinity. Okay, so now for the interval notation, we have to decide what to put on the outside of them. Infinity, no matter which one it is, gets parentheses by it. We decided a bracket goes here, a bracket goes here. Left-hand boundary, right-hand boundary. This one gets parentheses because it's an infinity. This one has a bracket because it had an equal to. Okay. So we put in numbers here to help us decide which side of this to shade. A lot of people get very confused. Okay. First of all, if you learn to shade whatever side that the inequality points to, you should know that that does not work. It doesn't work all the time. It only works if your variable ends up on the left-hand side, and it will not always end up on the left-hand side. So do not rely on this. Okay? I wish I could go tell all of your previous teachers to stop teaching you that way, because I'm constantly having to unteach it. Okay? One way to remember which side to do it. Of course, you can put in your numbers and you can just think about it. But here's another way of thinking about it. You're going to have some sort of inequality and it's going to point one way or the other. I call this the wide side of the sign, and I'll call this the narrow side of the sign. Because it's smaller over here, it's wide over here. You look to where your variable is. If your variable is on the narrow side, you're going to shade to the left of it. Here, my variable is not on the narrow side. It's on the wide side of the sign. So I shaded to the right. Narrow goes left, wide goes right. You can remember this because wide and right both have an I in them. So they go together. The narrow will go to the left, or plug in numbers, whichever way works for you.